Okay, cool. Hey everyone, I'm Will.
I'm Erica.
We are PMs on the C++ cross-platform team here at Microsoft, so we're going to chat a little bit about how some tooling can kind of make your cross-platform development lives a little bit easier if you're doing cross-platform development, because there's a lot of complexity in that sometimes. So a lot of this talk is going to focus on CMake, so just a quick poll of the room, how many people are using CMake actively for development? Okay, fair number.
Not well, but
Yeah, not well. That is understandable, so hopefully some of this stuff will make that a little bit easier, but yeah, we'll see. So CMake is very popular in cross-platform development for a number of reasons. I think recently we went through the top couple thousand repository, C and C++ repositories on GitHub, and I think a little less than a third of them were using CMake, and that wasn't even filtering to cross-platform projects, so it's very popular, especially in open source. There are a number of reasons for that. CMake can make your life a lot easier if you're doing cross-platform development. It has a pretty good set of defaults for targeting, getting your build working on a number of desktop operating systems. So whether you're targeting Windows, Mac, Linux, whatever distro of Linux you happen to be targeting, it usually will do that right out of the box. And if you are trying to target something else, it's very customizable, so with a little bit of custom CMake script, you can get it to target mobile devices, embedded, even cross-compiling scenarios, cross-compiling for microcontrollers, and even some more exotic stuff like WebAssembly if you really want to port some code to run in the browser. CMake also is itself cross-platform, and that might seem kind of obvious and cyclical, but if you're comparing that to something like Makefiles, where you have a million different variants of it, say, from OS to OS especially, but even different distros of Linux sometimes have slightly different behavior between your different ones. What that ends up with is you just have like forked build trees that you have to maintain completely separately, whereas when you're targeting stuff with CMake, you have one set of truth. Sometimes you have to customize it a little bit to get it working on particular OSs if you have different dependencies and whatnot. But for the most part, for targeting CMake, it's CMake other than maybe minor version differences, but the syntax doesn't really change that much. So once you get it working, it's usually pretty good. One of the places where CMake is a little bit trickier to work with, especially when you're doing cross-plat development, though, is getting projects into your IDE and working with them there, because traditionally the way that you work with CMake projects is you fire up your command line or bring up something like CMake GUI to configure it, and you ask it to build whatever assets you need for the IDE on your OS. So if you're on Mac, you can generate your assets for Xcode. If you're on Windows, you can generate your assets for Visual Studio, and you'll have MS Build and solution files. But that has a couple of drawbacks. So one, if you just need to edit some code quickly, that's a pretty decent editing experience. But if you need to change the actual CMake source itself, like if you need to add some files or change some compiler flags, it will completely regenerate all of your build tree, which will change out the projects out from underneath the IDE. In Visual Studio, if you do that, that means you need to basically reload the entire project, and if you've worked with any large projects in Visual Studio, you know that that can take quite a while sometimes. One of the other drawbacks to that is once you generate your build tree with CMake, if you're generating for a particular IDE, you're locked to that particular building for that particular platform. So if you're working with cross-platform code, you would need to potentially generate multiple build trees, and you might not be able to open those all in the IDE that you want to work with. So we've tried to make that a little bit easier in recent versions of Visual Studio. So I think starting in VS 2017, but we've put a bunch of improvements into it in the latest version. So I'm going to show you how you can work with CMake projects now in Visual Studio. So now you can actually just open the projects directly without having to generate anything, any sort of solutions or project files here. So I have a project that I've cloned off GitHub here called SuperTux. It's a open source game, 2D platformer where you guide a little penguin around and collect coins. It's a cross-platform application, so it builds on Linux, Windows, and Mac, and like a lot of open source cross-plat applications, it is built on top of CMake. So it also, like a lot of open source applications, has a lot of dependencies that I'll get into a little bit because that can also be a little bit tricky to work on. So just load that. So if you're used to working with projects and solutions, this might look a little bit different than what you're used to. This is just basically loaded the entire, basically it's just loaded the folder tree into Visual Studio. And I don't know, has anyone actually used the CMake integration in VS here? Okay, one. So basically the way this works is it just shows you exactly what's on disk. The advantage of this is you don't have to generate any sort of VS specific assets here. It just works against the CMake code directly. And it basically just detects, I have a CMake project here, it's detected there are a couple of things that it can run based on it. But before we get too much into that, one thing that I want to take a quick step back on is how I actually set up all of the dependencies here, because that can be a bit painful on Windows. So if you've ever set up a lot of dependencies, and I think this application, even though it's just a quick game, I think it has like 10 or 11 top-level dependencies, and then those all themselves pull in some other stuff. Setting up a dependency tree to get your environment working, especially on Windows, can be real pain sometimes. You kind of have a couple of options for doing that. One is to, if you get lucky, you can find a couple of, find actual binary distributions of the libraries online, but there are a lot of ifs with that. You need the version that you actually depend on for your project. It needs to be built with a compatible compiler. It needs to have all the flags or all the features that you want actually turned on and compiled into it. Hopefully it would have sources and debug information along with it so that you can actually debug into it if something goes wrong. And when you're trying to do that over 10 or 11 dependencies, realistically for real world projects, you're not going to find those dependencies very often in a pre-compiled form on Windows. So what usually ends up happening is you have to build everything from source. And that gives you complete control over the version, the build, and everything else, but also means you're building everything from source. You're also probably building it from source with instructions in the README that have not been updated since Visual Studio 2008. So if anyone's had to do that, that can be a real pain. Luckily, tooling can help. So one option for doing this and how I set up the dependencies on this machine, I used Vcpkg. So it's one of a couple C++ package managers that can help you get your dependencies. Vcpkg is cross-platform, so it works on Windows, Linux, and Mac. Last time I checked, it had over 1,000 libraries in it that it can bring down and build from source. So I'm going to show you how I set that up. It's super easy to get up and running. The only dependencies that it has are you need a working compiler, and that can either be MSVC on Windows or Clang or Linux, or sorry, Clang or GCC on Linux or Clang on the Mac. And basically, getting it up and running is pretty much as simple as just running a git clone from our GitHub repo. Vcpkg, and once you have that, all you have to do is run a bootstrap script. So I have that here. You basically just run the bootstrap script batch file, and that will actually build the Vcpkg tool and pull down a few other things. So Vcpkg has tight integration with CMake, and so it uses that to build, and it will integrate with CMake projects. So if you don't have CMake on the machine, it'll pull it down. It's pretty easy to get up and running on CI servers as well. Like you don't need a full graphical environment or anything like that. And it doesn't have any sort of coupling to Visual Studio, so it should work with pretty much any IDE and on any platform. So once you have that up and running, you can register the system by running the Vcpkg integrate install. And that just sets it as the default Vcpkg installation, because you can have multiple of them if you need to have packages with like conflicting versions or anything like that installed. And once you do this, Visual Studio will automatically pick it up, but you can also see it prints out this toolchain file when you do that. You can hand that toolchain off to any CMake configure, and it will automatically bring in all of the packages that you've installed in this this single install of Vcpkg will just be available and work. So installing packages is also super easy. Vcpkg install, and you can basically just boost or whatever dependencies you need. The SuperTux repo that I have here actually has a script that does all that for you. So I'll just grab that real quick. And basically that just shows you all the dependencies that it needs. This automatically finds the installation of Vcpkg on here and installs them. Not all projects come with something like that, but it's usually pretty easy. You just copy and paste a list out of a README and you'll have all your dependencies. So that was way faster than it normally is because I've already built all of these libraries, so they're cached on here because I'm sure none of you actually want to sit, wait, and watch through that while that's building. But instead of having to figure out how to build all this stuff yourself, Vcpkg will go pull down all the source code for you, apply any patches that it needs to make sure that everything is compatible with each other, build it, and then you can go grab a cup of coffee or something instead of pulling your hair out with instructions that haven't been updated for Windows since the dawn of time. Also, once you've installed the packages, you can see here it actually prints out the instructions on how to use them in your CMake project. That's not as relevant when you're just trying to set up an environment for a project that already exists, but when you're building a new one from scratch, if you want to integrate a new library with it, take a new dependency, this makes it a lot easier because you basically can just grab this, copy it in, and make sure that it's going to the right target. Yeah?
Excuse me, could you please set the command prompt to use larger font? It's hard to see from
Oh, sorry about that. Yes. Is that better?
Yes, much, thank you.
Great. So that's how I got the dependencies up and running. Just going back in here. So Visual Studio will actually automatically detect that installation of Vcpkg that if you run integrated install. So if I run the cache generation here just to rerun that to show you what it looks like, and it's going and pulling in all the dependencies here. This might be a little small, but it basically says found using the Vcpkg toolchain file, and then it pulls in the path to that toolchain that you saw when we ran integrated install. And if you're targeting a Linux machine, it actually will also pull in the toolchain from the Linux side as well. So we'll show that in a little while. So I have my CMake project here. Pretty much everything that works in Visual Studio with MS Build based projects in terms of editing and debugging works with CMake projects as well, even when you just open them directly. And so I'm going to grab a source file here. One thing I want to show you, sometimes some projects aren't particularly well organized on disk. A lot of times projects will just throw all their code into one folder, even if they have like a number of targets. So if you want to see the logical structure of the CMake project, if you grab this drop down here, you can actually split it out into the various targets that this project has. So if we go to the executable here and look at the source, we can see that this SuperTux executable actually doesn't really have much going on, but the reason for that, if we look at the targets that this is referencing, pretty much everything is going on in this library here. So this gives you a bit of an idea of the structure of the project. So I'm just going to go grab a file here. Badguy.cpp. And we have pretty much all of the Semantic Intellisense working now with CMake projects. So if we try to use any sort of auto completion, you should. Oh, yep. No, but I don't know if that'll make the actual UI any bigger.
You can do magnifier.
You can change the environment.
Oh, I might.
Or magnifier.
Actually, hold on, let me try this. Oh boy. That might have been a mistake.
Oh, that's good.
That's better.
Okay. Okay, that seems to have worked. So all of the member lists, and this is Semantic Intellisense. So you'll get it's not just tag parsing it; it's actually running design time builds to figure out what all of the basically how each of these translation units is built and is going to be built in the actual build. So this is going to be fairly accurate. Also, we have navigation features. So, for instance, if we want to see like where this stuff is defined, that is a little bit small in the 175% zoom, but there we go. We also have comprehensive find all references that works across the entire CMake project, and this actually also enables a number of refactoring operations that should be able to basically. You can have accurate refactoring across your project as well, just like you would have with regular MS Build projects and solutions. So you have that working as well. So I'm just going to make this file dirty. So building this, one of the advantages of being able to not open file, not having to generate solution files and project files is we can actually decouple the way that we build it from the way that we open it in the IDE. And we're actually not using MS Build to build on Windows here. By default, we actually use the Ninja build system. We've found that it tends to have faster performance for large code bases, especially when you're doing incremental builds. Like, for instance, if I have no changes here, it pretty much just figures it out almost immediately that nothing has changed and it's done. Last thing that I want to show before I'm going to hand it off to Erica to show a couple other productivity features in Linux targeting is just the debugger that we have here. So I've dropped a breakpoint here. Just going to start this up real quick. Oh, that looks interesting. All right, apparently we get to listen to the music for this.
I think this is the first time we've had tunes at our talks.
No, we had the music from the Yoga Gals.
Well, that's true.
Okay, so I'll just start again real quick. And I'll just run face first into an enemy here. So this is this has hit the breakpoint that I have here. This has basically the full support of the Visual Studio debugger in it. So I have breakpoints, data breakpoints, conditional breakpoints, and all of the locals, all the visualizations that we have here for data types in the STL. If you have your own complex data types, we also support something called MapViz, so you can basically annotate how you want to display your own data types to follow pointers and other complex data structures in a more human readable way here. So I'm just going to step through a little bit of this. And right there is where it determines whether someone ran face first into it or actually jumped on top of it. But we're in Visual Studio, so we can just drag the instruction pointer a little bit. So let's see if I can get this to land in the right place. There we go. So let's say we did actually land on top of it, and if I go back here, hey, I didn't die. So, you know, key scenario, you can cheat at games using the debugger. I know that's really critical. But with that, I'm going to hand off to Erica to show a few more things.
Yeah, so I guess I'm quickly going to run through, as Will was mentioning, over the past couple of years, I guess, one of our goals has been trying to make your Visual Studio experience using our native CMake support the same as if you were using an MS Build-based project. And so with the latest release, we made a couple more gains there. So I'm going to walk through some of the things available to you. Did it reset all my...
Yeah, it looks like it did.
Okay, that looks good. So I'm going to quickly walk through some of that stuff and then also talk about targeting Linux and how you can do that from Visual Studio using CMake. So Will did a little bit with the debugger, but I'm just going to show you something called just my code debugging, which I think is pretty cool. So I have this vector strings here called sound volumes, and I'm going to sort it. So call sort, pass in sound volumes. We also have something, normally IntelliSense suggestions are just ordered alphabetically, but now there's something called IntelliCode that uses the context of your code to suggest the most relevant suggestions for you. So it prompts with begin as a continue coding. It'll prompt me with end. So it trains on a couple of, or numerous real-world code bases like open source projects on GitHub, and gives pretty good suggestions for commonly used libraries like STL. And then I'll pass in a function called less than volume that's also defined here in this options menu.cpp file. Set a breakpoint that should be hit right when I go to the options menu, so I can show off another debugging feature. So I'll go to options, hit my breakpoint. So now working with CMake is just my code debugging, and so now if I press F11 to step into this line of code, I'm going to automatically step over any calls to system, framework, or other non-user code, so I won't be stepping into the implementation of vector or sort, and I'll automatically go straight into this less than volume function, which is my own user code. So that's pretty cool.
I'm sorry, could you repeat that? You're now able to skip over the SQL stuff?
Yeah.
Kind of a pain when it worked in Visual Studio.
Yeah, so this
So how do you do that? This is
it's enabled by default. I think it came out a couple releases ago, so like mid Visual Studio 2017, but I'm using the public 2019 build right now. So it's on by default if you're using CMake support or any of the MS Build based projects. And yeah, if you F11, it will skip over calls to system, framework, non-user code. And if you don't want that, you can go to Tools, Options, Debugging, and disable that feature. But yeah, any other questions, feel free to ask. Another thing for C++ developers especially we have is called Template Intellisense. So if you're working inside of a function template or a class template, you can now leverage the full power of IntelliSense when you're working inside those templates. So here, inside of this template, you can see that I'm not getting any member list IntelliSense. But I can go up here and provide sample template arguments for IntelliSense. So here I can specify an argument T is a roadblock, which is something I've defined. And now you can see I'll get relevant member list suggestions like get level, get type. And if I hover over R, I can also see that R is a roadblock. If I want to specify something else, so now it's a snowman, I can use this most recently used drop-down to easily toggle between different sample arguments that I've passed. Yeah, so that's Template Intellisense, and this is also in Visual Studio 2019. And then the last productivity productivity feature that I wanted to highlight is our code analysis. So code analysis now automatically runs in the background. So you can see down here that I have these green squiggles, like a warning. This one's warning me to use null pointer rather than null. For this specific code analysis warning, we've actually implemented a quick fix, so it'll just show me what that change would look like in my code, and then if I select it, it'll make the change for me. And the way that you manage code analysis in a CMake project is you have to add a file, and you can just do it by right-clicking, say, adding an item, and there's a template for a rule set file. But there's, oops, I want to use the supertext one, supertext rule set. You have these rule set files where you can just hand select which code analysis warnings you would like to be running in the background, and that can either give you warnings or errors. So depending on what you care about, you can inherit from different rule sets or select different warnings that you want to be running. And with CMake, the last thing that you need to do is pass this rule set file to CMake settings, so CMake will pick up on it, which I will talk about now. So in Visual Studio, all of the CMake configuration that is normally done via the command line is moved into a CMake settings.json file. And if you've used our CMake support in the past, you just manipulate all that by manipulating the JSON file directly. But now we've introduced an editor as an alternative to editing that JSON file by hand, which will hopefully make it easier for you to get up and running with CMake support in Visual Studio. So if I go to Manage Configurations, I'll make sure you guys can see all this. We have the CMake Settings Editor, which is basically setting up your configuration. So some general settings like configuration, name, type. You can see I'm targeting Windows. This is, as I'm picking up, I'm also using Vcpkg, and so I'm picking up on Vcpkg toolchain file by default, but here I could specify a different one. Things like your build root, command arguments that are passed directly to CMake. And also a new section called for CMake variables and cache. So I've already generated my cache, but I could click here to generate the cache and load a list of all of the CMake cache variables available for me to edit. And you can use this like you might use a tool like the CMake GUI to get a comprehensive list of all the CMake variables that are available for you to edit. If you want to edit any of these variables, you could just double click and edit the value column. Let's scroll up a little. Advanced variables per the CMake GUI are hidden by default, but I could click and see the full list, and I can also filter variables by name. So everything related to Boost or having to do with Vcpkg. And any modified variables are automatically saved to that CMake settings.json file, and variables defined there are ultimately passed to CMake via the command line. So to the left here, I have a couple of, yeah?
I saw the path you had to browse. Is other types of variables going to show correctly, like drop-down boxes and stuff?
So I guess for now, we support for paths. Some, if there is, so for example, the tool set that you inherit from, there's a drop-down, so you can pick what you want to inherit from, or configuration type, debug, release with debug info. And then some of them are, like command arguments is just a text box for you. So depending on the type of the variable, yeah. So the left here is like a configuration manager. So I have a couple of configurations set up already. The one that I want to point out that's new is opening an existing cache. So normally, if Visual Studio CMake projects, Visual Studio will create and manage the details of your cache for you. But now you can point Visual Studio to an existing cache, which gives you or your preferred tools complete control over your cache and your build tree. So for example, if you have a script that automates the way that you invoke CMake, you can continue to use that alongside Visual Studio for your IDE experience. So now I'm just I already have a Linux configuration set up, so I'll go over to that. The only piece of configuration I needed to do here was, again, get my dependencies using Vcpkg on my Linux machine. But again, Visual Studio will pick up on that automatically, so I don't even need to pass CMake my toolchain file. Did you want to talk a bit about the use case for?
Yeah, I'll chat briefly about that. So you can get all of your dependencies on most Linux systems through the System Package Manager. So I did want to chat just a little bit about why you might want to use a package manager that's more optimized for development. So Vcpkg is one of those, Conan is another. So one of the issues that you're going to run into with system package managers are their charter is optimized to keep the system up to date and running well. They often support pulling down development packages as well, but that's not necessarily what their primary use case is. It's going to have a few, that kind of manifests itself in a few ways. The most common is you're not going to have the latest and greatest, most recent version of any particular library in the system package manager. If nothing on the system needed it, they're always going to prioritize stability. Whereas a lot of package managers like Vcpkg, they're going to prioritize getting you access to the latest versions of any library so that you can actually use them in your projects. One of the subtler ones that you can run into with System Package Manager is it will sometimes upgrade the development dependencies that you have out from under you while you're developing, and this can cause a variety of issues. If you're lucky, it'll just break your build, you'll notice something is wrong and you can correct it and move on. If you're less lucky, you'll dynamically link against something that will cause some obscure failure at runtime, and then you'll have to chase down that rabbit hole to figure out what happened. With Vcpkg, you're in complete control over when those updates happen, so some automatic system update or installing a new package that happens to have your development package in the dependency tree isn't going to change anything out from underneath you. One of the other reasons why you might want to use something like Vcpkg across all the platforms that you're targeting is just consistency. So you don't need to include a bunch of fine package scripts for whatever your various dependencies are that work across every distribution that you might end up building on. And special casing, basically Windows, Mac, and Linux for finding your dependencies however you need to on that particular system. So that's one reason. And that's not to say that you need to do anything special to use Vcpkg. If you have all that special casing, it still will work, but you sometimes can clean up your build authoring a little bit if you are using a package manager. So that's all I want to say about that.
The last thing I realized I wanted to show you is actually connecting to a remote machine if you are trying to target Linux. So I'm connected to a VM here on my that I've already set up to, but if you wanted to add a new connection, you can just click on the connection manager and then pretty easily add a new one. We don't have a lot of restrictions on the distro that you're connecting to. All we require is a couple of dependencies on that Linux machine. So a working C++ toolchain, GDB, rsync, and then we use zip for a remote header sync that I'm going to show you guys real quick too. But that's all you need to set up and connect to your remote system. So I've already done that. And then I just selected my Linux release configuration and the proper target, and I can hit run. I have a couple of VMs. I hope that was the right one that I hadn't. Trying to generate the cache again.
Why does Visual Studio so badly overload the output tab? Why does it have a separate tab for different types of outputs? You constantly have to switch back and forth.
Toggle between them.
Yeah.
Yeah. I guess I'd be curious to.
Would you like them all mixed?
Yeah, would you like them all? I would be curious.
Yeah, I'd like to see a bunch of the ones across the bottom.
So just
side by
unmix
side.
Okay.
Also, finding files, it bugs me, you can only select 2 of them. Why not every time you do a find a file, it actually spin off a new tab rather than getting rid of your last results?
Okay, I'm still using an internal preview because I haven't updated from my last demo, so I was using the actual publicly available. I think I was connected to the wrong VM, which is not spun up right now.
I think, did you want to use this one?
No, I think it'll, I mean, it should work now. Once it figures itself out. Alright. Oh yes, now it is copying files to my remote machine, so I think it's found it. Any other questions while our sync is figuring itself out? I'm happy to take them. Yeah?
When you install Vcpkg, there's the toolchain file.
Yeah.
What's in that toolchain file? I guess that makes it special.
Yeah.
So I can show you that after the talk if you want. Let me try to- So it's in the Vcpkg GitHub repo too. It's a static file, so that's not one of the things that's built by
So I'm just
the
curious, will Vcpkg relies on that toolchain being passed?
Yes.
So you can't just forget that and then use the native compiler, it will not, find packages will fail.
Yeah, so find package, if for some reason you couldn't use the toolchain, it's not too hard to put the paths in place that you need, but it's a lot easier if you can. And I know some people who we've talked to that use toolchains to customize the build, like if they're cross-compiling or something like that, they've had good luck just chaining in the Vcpkg toolchain to their first toolchain. So it's fairly resilient against things like that. What is there a reason why you wouldn't want to include that, or just?
For that reason, I
Okay.
mostly cross-compile. So
Yeah,
I have
so-
a pretty complex toolchain
Yep.
already.
Yeah, so most of the toolchains that we've come across so far have played fairly nicely with the Vcpkg toolchain. Depending, it actually has, there's a variable you can set to pull in, to chain in another toolchain after the Vcpkg one, or you can just chain it in manually somehow if you need to.
All right, so after a little bit, this is now running on my Linux VM. So it's the same experience as on Windows. Yeah, if you run into any issues similar to I did, we really do listen to your feedback. So please let us know if you're having issues. But with the public building, you should not. And the last thing I wanted to show real quick is, as I mentioned, our remote headers. So I'll go to here. Open that up. So here, if I hover over the path here, you can see that we're pulling all of your headers from your Linux machine. So it's being saved in this remote header cache, Linux header cache, and this is my remote connection. And that just enables Intellisense exactly as if you were working on your remote Linux machine, which should make editing code from a single IDE while targeting multiple platforms better experience. And I think those are all the features that we wanted to talk about today, but we'll open it up for any more questions. I guess quickly moving forward, our goals as a team is to make this native CMake experience as comfortable and as similar to MS Build projects as we can, so that extends to both targeting Windows locally and also targeting Linux. The same kind of stuff that you would expect from Visual Studio, we're trying to bring into and achieve parity in Visual Studio. So if you have any feedback into what you'd really like to see, what tools are lacking here, what's really important to you, we'd like to learn from that. So any feedback, questions, anything we'll take now. Yeah, you can go ahead.
Speaking of parity, what are the plans for Visual Studio Code? Is there, I realize you're off in a different building probably, and you might not talk with them so much, but I mean, is there also a movement to bring in more features to Visual Studio Code that will start to approach what's in Visual Studio?
So I'm not sure if I can speak to exactly what they're doing. If you're, I know they have been adding like better support for things like find all references and things like that to get better navigation experiences, better colorization and editing experiences. I know VS Code is becoming more and more like an IDE, but I think it's always going to be a little bit lighter weight than, than Visual Studio itself.
I accept that, but I was just wondering if, if we should start to maybe approach it a bit.
But yeah, so they are adding more and more IDE-like features. Like I know one that was added recently for the C++ extensions to VS Code, automatically handling precompiled headers like we do in Visual Studio. So like we are trying to get there.
Gotcha.
Yeah.
I'm not knocking this. I'm just
Yeah.
Oh no, I know, but like if you're on Mac or Linux, VS isn't an option, and
Yeah.
a lot of people are.
Well, I
so.
mean, you do remote, but yeah,
Well,
you might.
fair.
Yeah.
But if you're on an airplane or something.
Yeah.
Yeah, was you had a question as well?
That answers it.
Okay.
Okay.
Just the question had to do with the sort of the mindset is that your front-end machine is a Windows machine. That's where you start and that's where you end. There's no front-end machine that's not a Windows machine in your whole worldview there, and that's clear.
Yeah, I
Yeah.
think our answer for that, not that scenario is VS Code because, yeah, VS is only for Windows. So.
Oh, other compilers.
Oh, yeah.
For example, I tend to use on both Mac and Linux compilers from Intel. There's a compiler set, and I several years ago did head-to-head set, and they beat out GCC, improved performance-wise, quite significantly, especially if you tweak it a little bit for the machine you're on.
Yep.
And how hard is it under the system you're describing to pull in compilers that are not officially those that are supported by CMake?
It is definitely doable if you, so as long as you can get.
I mean, I do it under CMake.
Yeah.
I just
If it works from the command line, we will build with those compilers. So if you change the path to the compiler that you configure CMake with, VS will build with that compiler. The IntelliSense might not be 100% if it's not one that we support out of the box. So I don't know how good our IntelliSense is for, or how accurate our IntelliSense is for the Intel compiler. Because I haven't tried it, but build and debug should be working with compilers even that aren't supported. I'd love to hear how it works too. Let us know.
yeah. Well, I don't use
Well,
Windows
fair,
on my front-end
fair,
machine,
fair enough.
so
Fair enough.
I'm not there.
Maybe we'll try it. Do you use VS Code at all?
No, actually, I use Sea Lion,
Ah, okay, yeah.
and that's an IDE that you can actually run on
Yes.
Yeah.
all three platforms,
Yeah.
and I do on all three platforms.
Have you used their, so they also, I think, recently started supporting remote builds. Do you use that at all?
Not yet.
Not yet, okay.
Well, we have machines for all three, so we don't have to do remote builds. And if you have the IDE,
Yeah,
why do a remote build?
makes sense.
Saves a lot of complication. I was doing remote builds for years.
Did you have a question as well?
Yeah, I guess, is there any plan or ability to use like the system CMake in the future? I guess because I know you guys use the internal version of CMake, and I guess my use case is that I'm contributing to CMake,
Yes.
and so I'm trying to use it, the latest development version,
So we support that today. There is I forget exactly what the flag is called.
In CMake settings, you can specify a CMake executable flag. As long as you pass that, we'll invoke that one instead of whatever we shipped at DS.
I only
And-
used it in 2017, and I think it complains.
Yeah, so I think that's new in 16.0. So Visual Studio 20.
And depending on which version you use, there might be a few features of the IDE that don't work, but for the most part, everything should just work. It tends to degrade pretty
Don't
so.
quote me on it, but I'm pretty sure in 2017 you can also just swap out the executable in program files. And
Yeah,
call into
that,
the same way.
I'm pretty sure that works too.
Yeah.
I don't
That's probably
recommend or
something
condone it, but.
I'm worried right now.
Issue some bullet points.
Alright. Well, yeah, you guys can reach out to us if you have follow-up later, but thanks.
Thank you.
Yeah, thank you.